I decided to make a video for a few of the more challenging questions that you will encounter in your journey through the exam 3 module on uncertainty and risk. There are certain problems where the probability calculations are challenging, and there are other problems where the calculations of expectations or standard deviations are also challenging. The particular question in this particular video is a problem where in a normal model, you're given a probability, you are given a value of a normal random variable, and you're also given either the mean or the standard deviation of the problem at hand. And then you are to solve for the remaining missing parameter. The two parameters of a normal model that are commonly usually given are the mean and the standard deviation. But in this particular problem, one of those parameters is the missing variable, and the actual probability and value of the random variable for that probability are part of the information given. In my case, this is quiz 7, problem number 4 of 9, but it could be in your quiz 7 any of various questions at hand. So the first thing I'm going to do is note what I have and what I need to solve for. And what I have is, in part A, I have the mean of this normal model given to be 1,500 units of value. And I also know that 20% of the graph is below 1,450. I note that this 1,450 is below the mean, and so that the correct graphic for this problem is graphic A, where the middle is given at 1,500, and I'm interested in this gray area being below the mean, below 1,500, and in fact below 1,450, and that gray zone is only 20% of the whole volume of this particular graph. And my unknown in this case is the standard deviation. The key to solving this problem for the second part of estimating the standard deviation is to remember that in chapter 3 we learned something super useful about the relationship between a z-score and a value, and that is the z-score formula. So I'm going to go away from the quiz question involved, and I'm going to look at the original formula that connects the z-score of a value to the standard deviation of a value. So we know that a z-score is when you take a number and you compare it to the mean of that number, and you then divide that difference by the standard deviation. So that's a formula for a z-score. A z-score measures a location of a number by first finding the difference between the value and the mean, and then second, dividing the difference by the standard deviation. And what you get from doing this formula is a description of the location of x, the location of a value, from the mean in units of standard deviation. Now, notice that this formula has 4 parameters, 4 ingredients. You can call these ingredients parameters. Those are synonyms in this context. So by knowing any 3, of the ingredients, we can solve for the fourth one. And that's the critical insight in order to solve this quiz problem, that knowing any three would give you the fourth. So in part A of this question, what am I given? I'm given the mean is 1500. I'm given the value of x is 1450. And I also know that values of x below 1450 make up 20% of all the possible values of x. And I am asked, what is the standard deviation? So with this information, what additional knowledge do I need in order to solve for this particular standard deviation? And the answer is that the standard deviation formula would require me to know the value of x, the value of the mean, and some z-score, some standard value z-score related to 20% of the model. Okay. So to make this work, I already know x is 1450. I already know the mean is 1500. And then I would need to figure out what z-score to get. What is the z-score that that is related to separating 20% of the left-hand side of a model? So I'm going to go into the normal model and look for a z-score such that I can find the dividing factor between the bottom 20% and the top 80% of the two. And that can be given to me via the normal calculator. So I'm going to use the normal calculator to find this z-score that I need. So let's go back to the test. You may notice that the test has a question help that allows you to open StatCrunch. So I'm going to open StatCrunch in a new window. When StatCrunch finishes opening, I'll share it with you. And I'm going to go Stat Calculators Normal. And currently, the calculator is set to divide the graph into two equal parts of 50%. 50% below 0, the z-score 0, is 50% in white above the z-score 0. So if I change that 50% to a 20%, I get that the optimal value of the z-score in question is minus 0.8416. So now I have found my z-score, my magical z-score that separates the bottom 20% from the top 80%. A z-score of minus 0.8416. I go back to the whiteboard and I learn that this particular z-score is negative .8416. And so the standard deviation then becomes equal to the numerator of minus 50. That comes from the subtraction of 1450 minus 1500. And the denominator of minus 0.8416. I take any calculator, so I'm going to go back to StatCrunch. And in STATCRUNCH, I go data, compute, expression, and I divide -50 by -0.8416. And that's going to give me the answer to this part, standard deviation. And upon computing, I get that the standard deviation should be 59.41. So I put here 59.41. And here it says round to 2 decimals as needed, which is why I did that. And that is how I find the standard deviation. I will let you find the standard deviation for part B by simply following the same methodology and move to part C. You will notice how in part C, the standard deviation is given, as is an area above a certain number. And what I don't know is the mean. So now in part C is not like parts A and B. In parts A and B, we were looking for the standard deviation. In parts C and D, both, we are looking for what the value of the mean will be. So I'm going to take the information from the problem, and I'm going to look at 95% of a curve being above 10. So that would be graph D here. 95% is above 10. So that gray zone is 95% of the model. And I'm solving for the mean as opposed to solving for the standard deviation. So I'm going to take those ingredients back to a new whiteboard. And so what is it that I know? Let me escape the whiteboard and come back in so that I can activate the text element. So my goal is to identify the mean. That's what I don't know. And what I know, what I'm given is the standard deviation. And I am told that 95% of the area of this normal model is above the value of 10. So those are the given ingredients. Okay. So if I look at the normal model, I could look at the normal model in two ways. I could look at the normal model in units of standard deviation. I could do the same in units of x. And in units of x in particular, when I look at the graph of the normal model, I am told that there's this marker, and this marker happens at 10, such that above 10, for all these values of 10, now the z-score here is 0, and the mean is what I'm trying to solve for. The mean is what I don't know. I know that this area is 0.95, and I know that this area to the left of the marker, therefore, is the complement, the other 5% of the model. And so that's one of the two things I know. The other thing I know about this is that a z-score is always equal to a value of x minus the mean over the standard deviation. And so if I'm not clued in as to what the mean is, if that's what I'm solving for, I can rearrange these four terms so that I could have the mean being the value of x minus a z-score times the standard deviation. And currently, the value of the z-score of 10 is something I don't know, but it is something that I can solve for. I also know that x is 10 and that the standard deviation in question here is 0.4. And I can find out z by using the normal calculator. So once I have those three ingredients, my answer follows from that. So my mean is going to be equal to the value of x minus the 0.4 of the standard deviation, and that's being multiplied by the z-score here, which is negative 1.65. So where did I get that minus 1.65 z-score? That's negative there. Going to go back to StatCrunch. And I'm going to go into the greater realm, where this area is 95% of the z-scores. And notice how to cover 95% of this normal model from a certain marker to the right requires a z-score of minus 1.645 or minus 1.6448. So that's the z-score that separates the top 95% from the bottom 5%. And when I use a minus here, and a minus there, that makes this a plus. And then this 1.64 or 1.65 is going to multiply this by 0.4. So I have 10 plus 0.4, 0.64, 0.66. And this is going to equal 10.66 for the mean. In other words, this number over here is 10.66, which makes sense because it has to be bigger than 10. So in order to cover this. So now that I know that the answer for the mean is 10.66, I head over to take my test, and I put here that the mean is 10.66. So whenever you need a standard deviation, be sure to take the value of x, subtract the value of the mean, and divide by the z-score. The z-score is going to come from the standard normal graph. So in this case, where the mean is 0.65 and you're looking at above 0.73, then the z-score is the z-score that corresponds to the 11% above. So the z-score is for the 11% above the certain marker. So that's going to be found via the StatCrunch calculator. 11% above has a z-score of 1.23. 11% above should look like that. And this 1.23 is the z-score of the marker at the point 0.73. And what this ratio gives me is the standard deviation. So that's the formula and the process to calculate the standard deviation. That's the right formula. for the 3 ingredients that you need. And then when you're solving a problem about the mean, %7 is below 207. The mean is the value of x minus the z-score times the standard deviation. So it's the 207 minus the 7% z-score. 1.6 times the standard deviation of 205. Okay, so the mean is minus times a minus 1.6. Okay, so where did I get this negative 1.6, folks? I get this by plugging it into the calculator. Okay, so I'm going to go back to the normal calculator and finding the 7% on the less than side. And that's minus 1.48. You'll notice that that the negative and the negative give you a plus. So I'm going to have 207 plus about 307. And so I end up with 514. And that's a pretty close estimate of the mean in this problem. Okay, so those are the 2 offshoot formulas from the z-score formula we learned in chapter 3 that you use depending on what it is you are looking for. When you're looking for the standard deviation, you solve the standard deviation by rearranging the z-score formula. And when you're looking for the mean, you do the same, but you're solving for the mean rather than for the standard deviation. Okay. I hope this session was useful, and I hope this particular video helps you with this problem.